Welcome to this episode of our video series. In this part, we will teach you how to set up a project, write your first code, and see it run. Does that sound exciting? Let's go! We start off with an empty session in VS Code. On the right you can see the terminal window, which we will use to call shell commands. We'll need this in just a moment. To make things simple, we begin with a skeleton project structure. We can use Dune to create it for us by calling Dune init project hello. This will create a new project called hello in the current directory. This is super quick to do and means that we already have our project ready to go. To take a look at what we have created, we can use the tree command, which displays the contents of our folders and directories. As you can see, it has created a Dune project file to configure a project, a lib folder that is meant to contain library code, a bin folder where we can create binaries, and a test folder where we can store our tests when we write them. There is also an _build folder which contains the output of the build system, like the created artifacts or build logs, but typically we won't need to care about its contents. Now let's look at the bin folder where we can find a file called main.ml. As you can see, it only contains some code to print hello world and a new line at the moment. To compile it, we type Dune build into the console session. This does not produce any output nor any error messages, and that's how we know it has finished successfully. To run the code, we use Dune exec. The format of the command is Dune exec name of the executable. In our case, it's hello, so we can use Dune exec hello, and we see that yes, indeed, it does print hello world. In fact, the Dune build step is optional, as Dune will automatically build the executable if you try to run it. But it can still be helpful to separate building and execution steps when working on a project. We can also use watch mode, which means that every time a file gets changed, your project gets recompiled. We can enable it with the command dune build-w. Once we start it, let's check that it has worked. Let's mess up the source code, for example by removing the double quote. We get a syntax error. We can fix the syntax error and create a different error. Let's say that we claim that we expect an int. In this case, we get the type error telling us that we expect an int, but the actual type is unit. Notice that when we undo all our errors and save, the compilation succeeds again. Watch mode is not just limited to the build command. We can also use watch mode to execute commands. So whenever we change hello, our code gets automatically rebuilt and rerun, and we can see the results directly. Let's try it out by changing the message that we want to print. We change the message, save, and you can see it prints hello OCaml community now. Success! You might wonder how OCaml knows which code to execute when a binary is run. Unlike other languages, there is no magical entry point function which is called in the beginning of your program's run. Instead, OCaml will execute all the code that is on the top level when it starts a program. In fact, there isn't even anything special about the name of the module. It's called main in the skeleton project, but we can also rename it. Let's name it print, for example. To do so, we need to rename the file. However, we also need to edit the Dune file which contains the instructions for the build system and tell it that the module is called print now. After this is done, we can run Dune exec hello and see that it still works, still finds the right code to run, and prints hello world again. Now let's talk about modules for a bit. In OCaml, code is organized into modules, where each ML file maps to a module. To refer to a module, you use the name of the module, but with the first letter in uppercase. For example, let's use the built-in printf module. The printf module has a lot of useful functionality for printing values to the screen. Here let's replace print endline with the printf function from the printf module. Functions in modules are accessed via the module name, a dot, and the function name, just like in many other languages. Then come the function parameters. In this case, we pass two parameters to printf. The first parameter is the format string. Those of you who know C will find this familiar. %s means print a string, and \n means print a new line. The second argument is what to print, in our case the string hello world. When we execute it, we can see that, as expected, it prints the same thing as before. Let's look at how to create new modules. We create a new module by creating a new file called en.ml. Within this new module, we can define a new value called message that contains our message hello world. Now we save this file as en.ml within the lib directory. In a previous module, print.ml, we referred to this as hello.en.message. We can confirm this works by building and running hello as we did before, with Dune build and Dune exec hello. We can also check our exposed modules in our OCaml REPL called utop. To do this, we type Dune utop in our terminal. This opens a utop instance. Within utop, we can inspect our en module by typing #show hello hello.en followed by 2 semicolons. We see that the en module contains the value message, which is a string. We can also define multiple modules in the same library. Let's see how. Suppose you want to create a new module and define the same message in OCaml's native language, French. We create a new file in the lib directory fr.ml. Within this module, we define our message value bonjour monde. Let's reference both modules in our original file, print.ml. We copy and paste the original line and change the new line to hello.fr.message. When we run this again, we've printed both the English message and the French message. All the modules we have defined until now only contain values, the message in French and English. We can define these in a JSON file and read those values in OCaml with a library called Yojson. We make this known to Dune by mentioning that we're going to be using the Yojson library in the library stanza. We verified the library is usable by building the project again. If it's not present, we need to install the JSON library first in the current switch with the command opam install Yojson. So we go ahead and create a file called data.json, which contains a JSON object mapping a language code to the message we want to print in that case. Let's go back to our hello module and define the necessary code. The first part is to load the JSON data into a value. We call that allLength. To do that, we can use the yojson.save.from file function and the name of the file. This will make Yojson parse the JSON and store it in memory. The other part is to get the relevant key from the JSON data. We create a function called get, which takes a parameter called lang to return the message for that particular language. We pattern match on the allLength to make sure that what we got is an object. In that object we use list_as_sog to find the key that matches the language and return it to the user. With this function in hand, we can adapt our print.ml by replacing the hard-coded messages by JSON lookups. Thus we call hello.get with the language code. Since we have defined English, French and Spanish so far, we can try all 3 of them. When you execute the program, you can see all 3 of the messages printed. Now if users want to change the message, they can just change the text in the JSON file, no need for you to recompile the code. This concludes our small tutorial on writing a slightly more involved application in OCaml. We hope this was helpful to you, and check out ocaml.org for more documentation and tutorials.